Okay, so this video is to explain these two problems from the section 3.4 practice. Okay, so for this equation, since we have a constant in the equation, we have the 1 on the right-hand side here, that tells me that we're not going to be able to use the one-to-one property to solve this equation. Instead, I need to get the left-hand side to be written as a single logarithm and then rewrite the statement in its equivalent exponential form. So looking at the left-hand side, since that's subtraction between the two logs and they're both log base 10, I can use the quotient property for logarithms and rewrite that as the log of 2x minus 5 over x minus 3 equals to 1. Okay, so now to rewrite in exponential form, that's going to be 10 to the first power equals to 2x minus 5 over x minus 3. And then just showing the arrows, right? 10 to the first power equals to 2x minus 5 over x minus 3. Since we're solving for x, we need to get x out of the denominator. So to do that, I'm going to multiply both sides of the equation by x minus 3. So that would be 10x minus 30 if I distribute the 10, and then I'm left with 2x minus 5 on the right-hand side. And now this is just a linear equation. So subtracting 2x from both sides and adding 30 to both sides, and then dividing by 8, that gives me 25 over 8, 25/8. And then you just want to double check that the solution makes sense, that it's not an extraneous solution, because when you have a logarithmic equation and then you do something like rewrite the equation in the exponential form where the log is no longer there, you lose the domain restrictions, similar to like when we would square both sides of the equation, and we potentially lost domain restrictions. You need to check to make sure that the final solution does make sense. So if we look at plugging 25 over 8, which would be 3 and an eighth, right? 3 and an eighth, back into the original equation for x, well, 2 times 3 and an eighth, or 2 times 25/8 minus 5 would be positive, so that works, that's okay. And then 25/8 is, like I said, 3 and an eighth, so minus 3, that would still be positive as well. So this works. Yes, this works. And that is our final solution. Here, I'll box my answer. Okay, so then you also asked about number 67. Okay, same kind of thought process as the previous problem where I have a constant in this equation. So one-to-one property is not going to work. So let's think about rewriting the left-hand side as a single logarithm. Both of those logarithms on the left are log base e, right? We're writing them as natural log. So I can use the product property for logarithms to write the left-hand side as ln of x times x minus 2. Okay, now I'm going to rewrite in exponential form. So that's e to the 4th equals, I'm going to think about distributing that x in, so it's x squared minus 2x. And now this is just a quadratic equation. And I know it looks different than the quadratic equations you've worked with in the past. Sorry, that's e to the 4th. Because the constant is minus e to the 4th. So the value of c, I'm not going to factor this, the value of c in my quadratic formula is going to be negative e to the 4th. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So simplifying this, that's going to be 2 plus or minus the square root of 4 plus 4e to the 4th over 2. This would represent both exact values. I would take the exact values from here. We're going to also have to check for extraneous solutions, but this could be simplified a little bit more. I'm just seeing the common factor of 4 underneath the radical. So I'm going to think about factoring that 4 out, just so that I can think about taking the square root of 4, right? Because the square root of a times b is equal to the square root of a times the square root of b. And that goes back to exponent rules. This is all over 2. So then once we do that, that would be 2. I'll write that extra step. That would be 2 plus or minus 2 times the square root of 1 plus e to the 4th all over 2. So then that simplifies to be 1 plus or minus the square root of 1 plus e to the 4th. So I'm going to separate those two solutions and then check for extraneous solutions. Okay. And to check for extraneous solutions, I need to think about plugging into the original equation. Now, this solution right here would be a negative value, right? Because 1 plus e to the 4th, the square root of that is going to be a larger value. So that would be 1. You can also type into your calculator to get the approximation, but that's going to end up being a extraneous solution, a solution that doesn't make sense. And then the 1 plus, I don't have my calculator. I guess I could type it into, oh good, I have Wolfram alpha right here, just so we can see what the approximation is. So 1 plus the square root, is there a square root? I can also type that as the 1/2 power. So 1 plus e to the 4th, close parentheses, to the 1/2 power. Okay, so that's approximately 8.456. 8.456 is the approximation. Okay, so if I plug that into the original equation, it would work. I'm going to ask you guys on your test for the exact, to represent your answer as the exact value. So this would be the exact. That's not how you spell exact. Exact value. And then this would be the decimal approximation, rounded to 3 decimal places. Let's just confirm. If I made that minus, yep, that would be negative 6.456, and that, you can't take the natural log of a negative value, so that was an extraneous solution. So we cross that out.